Hi, everyone. My name is Ken Fogel, and I'd like to welcome you to this morning's session, Forking the Future, Embracing Microservices Evolution. Mohammed Taman is going to give us an excellent presentation. So let's not take away any of his time. Mohammed, it's all yours.
Thank you, Ken. I appreciate it. Hi, everyone. Good morning, good evening, based on where you are, good afternoon. And thank you for joining. So, yeah, this is the presentation about forking strategy. And I would like to speak about this strategy as it touches one of my migration strategies, and I face some challenges, some advantages and disadvantages, some stuff that we faced. I would like to share it with you. So again, hello everyone, and thank you for joining me today. I hope you will get best of this presentation. I would like to take all the questions at the end because whenever I go linear with the presentation, you will find me sometimes answering some questions from the previous part. So if I want to start off this presentation, I would like to say that tactical forking actually is a strategy for implementing microservices or in general like distributed system solutions that enhances your software development strategy and allows your software and your teams to grow. It's also enable you to deliver new features immediately using multiple teams and with a controlled transition to a microservices-based architecture. So those are the benefit you would gain from this kind of strategy. And let's go through the presentation and see how we can tackle all of these points and how we can get these benefits. So a little bit about me. Not too much. So I'm Mohammed Taman, a solution architect at Magna International. Magna International is car manufacturing parts, and also we're producing cars for different vendors, big vendors in Germany, America, Japan, and all over the world. We are 12 groups distributed around the world to produce all the car parts. So we have a lot of challenges regarding data and architecture and software and distributed systems and many things that you can imagine, because we have also different group and divisions within the same group. Because if you are producing powertrain, which is the engines, or cosmetics like bumpers and all of these kind of lovely parts that make your car, or electronics, or seatings and headlights, all these technologies that fit in one car at the end, or we producing the car from end to end, fully car manufacturing for some like bigger brand like BMW, Mercedes, Mini Coopers, Land Rover, Toyota Supra, and all of these kind of diesel-based or electrical parts. So there is a lot of challenges. So we're facing a lot of things. It's big organization, siloed, federated IT. So you can imagine how it is. I'm also Java champion. This is why here in this amazing conference, and I'm glad to be part of this conference as usual. And I'm an instructor and author. So I'm really excited to show you how to use tactical forking as a software development strategy and give you a realistic view of the possible challenges. So let's get started without further ado. So here is our agenda, but because when we deep dive into some strategies, we would like to know where it came from. And this is very important. So we will speak about architecture, modularity, and then what is tactical forking and when we can adopt tactical forking strategy. After that, how to adopt tactical forking in a technical way, and then the tactical forking impact on your team and development as the challenges that you should aware of, because there is investment here and business requirement. So this is where you can justify the move to a tactical forking for your business people, because it will require some investment. And finally, I would like to present you with some challenges that you might face during this transition, because it's all about trade-offs. There is no single solution that fit all problems. Even we are speaking about microservices. Microservices is not the silver bullet, point that we should use because it's a trendy. We will look fresh and new and modern. No, sometimes monolithic application is very suitable for your case. A modular monolith application, self-contained, there is a lot of like different use cases. So it's all about trade-offs. Just look at your use case justification criteria, then you can choose uh, the strategy for migrating your current software or you starting your software-based system. So if I want to speak about architecture, so before discussing technical forking, actually, it is potential as the approach and strategy for growing your software and team. We must first understand its origins. The key concept here is modularity. Why we need modularity? So we have to think and answer two very important questions. But I want also to mention that some of the modularity graphics here in this presentation has been borrowed from Mark Richards' architecture, modularity, and service granularity presentation. It's very, very great presentation. If you had it online, it will give you more insights that it's this presentation really complete because it's all about architecture. So the first question we would ask ourselves here is about why should I consider separating my application into smaller distributed components? And this is very, very important. And we will look at these kind of criteria now in this part. And the second one, yes, if I have a need for this kind of distributed system, how should I approach breaking apart my monolithic application into smaller parts? And this is the second part why I could consider technical forking to move into modular system and how to break it up into smaller parts. But first, let's see why I need to consider modularity. Why I need to break up my monolithic application into smaller services with the goal in mind also. And I have to bear in mind that moving into distributed system not easy thing, and it required challenges, a lot of like some investment, also orientation, how we can work, and different teams need to collaborate here. And also it will involve some strategies for this communication issues, more component learning curves. So, but everything is a trade-off and comes with a cost. One of the considerations that I would like to consider is maintainability of the software. Sometimes maintainability could break and take some time to come into into reality as a deployment. So maintainability here means when I have a new feature and I'm working on a monolithic application, and this new feature could break up the other features in the same existing application, and it could take much more time to deploy, or even when I deploy the code as a whole, because it's only one part has been changed, it will take time and it might break things that I didn't consider. So this is one of the strategies, that maintainability of the code, to make it smaller so the change will become independent and I can move forward. So to tackle this problem also, I would like to test my code. But imagine that you would like to test, you only test that part of code that you have changed, but you didn't test the whole monolithic application. But also you could have, if you have a good strategy for testing, it could be really, really big testing code base for all of this functionality in one application on the left-hand side, which is your monolithic application. But it becomes more efficient if you focus only on the domain service that's required to test, and it will be very easy and very fast to test and deploy, and to make sure that this unit is testable and easy to write testing code for it. I don't have to consider all the other parts. So two things now it will allow us to move into modularity is we need maintainable code and testable code that can be deployed fast and with less bugs. Deployability. Sometimes our business require frequent change. It's agility. It's business agility. Business agility means that I can deploy at any time to consider and catch the time, and to be time to market very fast to compete. And in order to do this, I cannot rely on one monolithic application that if I change part, I have to down my service for some certain time, because this is very, very a down issue for some businesses, that they cannot go down even for 4 or 5 minutes. And if you scale it up for making this kind of deployability, you are taking a lot of resources, because one monolith could have vertical requirement for your server that you need to scale up and down, as well as scaling horizontally out and in. So for easier deployment, that for each functionality individually that doesn't affect the overall system, you can do this easily by breaking up your bigger monolith application into deployable component that it has its own CI/CD component. It has their own test cases. It's maintainable, and I can deploy it any time. The other factor is definitely with deployability is scalability, because if you consider scaling out again your monolith application, I scale the whole functionalities inside this self-contained one application, which does not require scalability, while small part of this application is really need the scalability. So by breaking up this into services, the services that need scalability, it can scale out and in, and the others which require more computation scale can scale vertically up and down, and the others does not require. So you are saving your business bills. This is very crucial for the business. It's the money, the cost that you are using, especially we are all goes to cloud. And also the scalability that is elastic. I can extend my services and I can shrink it at any time. I don't have to do all of these kind of things also in my on-prem, or either using the vendor scalability features, or if you're using Kubernetes or container-based applications, you have both scalability side. And whatever you are making smaller, it's very easy to scale and also doesn't take a lot of resources, means it doesn't hurt your pocket or your business pocket, which they will love it. And finally, fault tolerance, because those kind of features to move to modularity is very important. Fault tolerance means if you have decomposed your monolith application into e-commerce search, recommendation engine, a payment service. So the payment service now has been getting down, has been shut down because there is problem or integration. Still your application working because people can search, can modify their cart, they can do their functionality, so they doesn't feel it. But when it comes to payment, I can have different strategy for different like backup service provider, but it doesn't break the whole application, all functionality. While in monolithic application, if this feature fall down, and the whole application will stop working, and you need to fix it and redeploy it, especially if you have a bug or problem or scalability issue or freezing. So the whole application will freeze. So those are the most important like criteria that will make us think about modularity. My business came to me, I cannot move forward anymore because my code is not maintainable. We need more people to work on the same code base. It's not testable enough. And I need to do a lot of like complex test cases because it's conjoined code base. I cannot deploy at any time because I also have to deploy the whole application. It takes a lot of time and I need to shut down. And I need my application to be business continuity, scalable, and it's very easy to scale and doesn't hurt my pocket. And if one component break up, it doesn't break the whole system. So this is how we can move to modularity. And now we have considered these criteria. How can I move? What I should ask myself? Which strategies I can use? Here, I will show you a very basic activity diagram and flowchart to understand, and you can ask yourself and justification. So if you have this first question about modularity, is modularity justified? Should I modularize my code? If it's no, please keep your monolithic application. But if it's yes, you have to ask yourself, is the decomposition visible? Can I decompose my architecture into smaller parts easily? If it's no, please again keep your monolith, and you will have different way of doing this. Because sometimes we have the visibility and impression that it's visible for decomposition, but it's only one functionality. It doesn't require this decomposition. So I can tweak and keep my monolithic application. Maybe it could be modular monolithic application if I would like just small parts inside. But if it yes, is it definable? So is it really defined, but there is separate logical code and packages separated from each other that I can separate, and there is definition between orders, accounts, different business domain. So in this case, it means that I need to move forward with modularity. But if it's definable component, please go with component-based decomposition and go in this direction. But if it's not visible and it's intertwined and conjoined and coupled work that is visible logically as a separate domains, but they are physically tied, not separable, please go to tactical forking. Both of these kind of strategy will lead that you are moving to distributed applications. And today we are going to speak about one of those strategies, which is tactical forking. So let's see what is tactical forking. So to explain what is tactical forking is and how it can be used as an approach and strategy for growing your software, we must first look at situations where tactical forking becomes an option. So to illustrate this, you have your typical software architecture. There is a backend service and some front-end applications, either separate applications or served by the backend systems. As your software architecture becomes more successful as a product, you start adding more features. This backend system, which contain all your business logic and the app's functionality, becomes increasingly large. And this type of extensive organically grown application is sometimes referred as, good point, monolithic application. With this continued growth, we usually start experiencing the challenges associated with this monolithic application. One of the first signs that we need a new approach and strategy is when we change our application in one place, for example, some functionality for our mobile application, and accidentally break other functionality for example, related to our web application. So in addition to this kind of breaking up the functionality, to this unreliability, another indicator for new approach might be that it can become quite challenging when we start growing our teams alongside with our software. We find that because we share the same code base between multiple teams, the teams can work autonomously at all and waste much of time ensuring changes are committed correctly, even though the odd issues, the odd bugs might slip through because we are all changing in the same code simultaneously. The obvious strategy change in this situation where we are dealing with this sizable monolithic application that begins being worked on by multiple teams is to start breaking up the application code into something like microservices so that each team has part of the code that relates to their area and to their business domain. But there is a problem with the most of these microservices migration strategy is that they always assume that your extensive monolithic application is internally well organized and structured into components that relate to specific functionalities and parts of your business. However, this is not always true, which is why some microservices really migration strategies failed. Your application might externally look well organized into different functionalities, into different business areas, but when you look at the code internally, and which is usually the case, all the code might be conjoined and coupled. And it's very hard to separate those different business functionalities into separate applications and microservices. The good news, there is always good news, this is where tactical forking actually becomes an option. I still say an option. It's not a viable solution. It becomes an alternative approach and strategy that you can use to grow your software and your team. This approach involves giving a copy of the entire code to each of your team and having some routing mechanisms that routes all the incoming requests to a different parts of your applications. It gives them the illusion of one backend system while giving your teams their version of the code that they can develop autonomously. So not only, by the way, just can each one of your business teams now start adding new features to their version of the code without having to wait for microservices-based approach, but they can also in the background start striping away code that's not related to their specific business domain and to their particular business functionalities and areas. So with this tactical forking approach, you will eventually end up with microservices-based system. But the key advantages here is that you won't have to delay any of your new features that business require, and you continue support the business agility. The migration to microservices becomes a background task while each team develops its version of the code with the new features. So, by the way, this strategy was first introduced and given a name by an individual called Fausto Dilatori. And in the rest of this presentation, we will look at my view and experience on how the strategy could work so that you can migrate your software to microservices-based system. Before we move on to the next section, here is the summary of all the key points mentioned previously. So you can use it to understand what is the criteria and what is tactical forking is, and when I can start consider it into as a migration strategy to the modular software. As in the previous section, I introduced tactical forking and briefly outlined situations in which it becomes an option. Before considering this option, we should highlight the specific scenarios in which tactical forking will be helpful for you. So I will do this by providing clear criteria that will help you assess its suitability. So again, let's get back to our example here, backend system and they are serving web application and mobile. The first question from this criteria asks, do you need a modular software architecture like microservices-based system? It's a very crucial question and it's very important because you have to ask yourself, should I keep myself using my monolith application and I start just evolving it? Does the functionality require this because it comes with functionality? I have a pain previously in one of our companies that I was consulting and I start working for them because we have a very bad situation with a system that developed for some big organization. And that system, actually people, when they think about the architecture of the application from the beginning, they says, okay, we are modern, we will use some tools, we will start working the system as a microservices-based system. And they used AWS as a cloud provider, and they went far with the decomposition. And they used a lot of tools because they were happy to use tools. You know, the tools are our toys. We love to use tools, different languages as well. So they end up after 6 months not going to production and extensively and very expensively paying a big bill for the cloud provider because even they weren't aware of the cloud strategies and cost saving strategies, and they have different environment like environment from development to QA to UAT and semi-production, and even they doesn't go to production yet, but after 6 months, they bankruptcy. They used all the investment money just to maintain this kind of. What if they goes production because of misunderstanding of the system and the decomposition involved into this? So when I joined, and then the investors stopped paying, the company bankruptcy, and they wanted to have someone to continue for sure, but in an efficient and cost-efficient way. So I was working with a great team, and we start thinking how first to recompose some of things. Like you can imagine user management service, they decompose it into profile management, user payments, user preferences, and as well as user authentications, like 4 services that could be under, and there is no scalability required, no any of the other consideration we have spoke about, they have to consider, but they just decompose it. Each service means individual CI/CD, individual ownership, individual tools, and repository and management. So it's cost. So this is why I told you you have to think about the trade-offs, when to use this and when not to use this. And you have to record it as an ADR, architecture decision record. It's very important because people might come after you says like, why didn't you use this strategy? Hey, we have documented our decisions and you can read about it. So people, they can get onboarded and see why you have taken such decision, why you use RabbitMQ instead of Kafka, because it doesn't suit our case. For example, why 1, 2, 3, 4. So when I know I'm aware of all of this, I will think forward how to enhance the rest of the software because there is decision. And also I can say, okay, we missed something here, I can enhance it. So I just wanted to give you this because it's very, every company that I consult, they have this kind of problem that following the trend and it doesn't follow the business criteria and case. Let's get back to our presentation. So about our first question, do you need a modular software architecture like microservices-based system? Yes, I will say yes, because this modularity allows you to change and upgrade the different business areas within your software separately. This separation will ensure that overall reliability of your system, basically changing one component, which is mean changing one microservices won't break other parts of your software architecture. So another reason for migration, implementing this kind of modularity and separation, maybe to enable multiple teams to work independently on growing and enhancing different areas within your software with minimal friction. Excuse me. Once we have answered these 2 main questions and the previous question about the need for modular software architecture, the next question in our tactical forking criteria is your software code base logically modular, as I have mentioned before? In the other words, does your software have distinct business areas and functions that can separate independently with their own functionality and data weight, like separate logical modules that are separable into something like microservices? This question is crucial because you can easily have the impression of separate areas within your software. Still, they all work together to provide data and functionality. And individually, they need more weight in terms of data and functionality to be recognized as independent logical modules. Once we have established logical modules, we must answer the following question before tactical forking becomes again an option. Are these logical modules physically separable using traditional techniques to separate code? If they are physically separable, please, because you have a well-structured code, use traditional techniques and avoid tactical forking, as it won't benefit you in this case. Use component-based decomposition. But, however, in most cases, tactical forking is the only option because even though you have the logical modules, they are physically too tightly coupled. The code is too physically intertwined, where these logical modules overlap, making it very hard to separate quickly. Therefore, traditional techniques to extract these modules, even though if you use it to separate these modules into microservices, won't work, or even if it works and you push it too hard, it will take too much long time and you will get complaint from your business. This is where tactical forking actually becomes viable. We have logical modules that are not physically separable immediately into something like microservices. So, in summary, I have summarized the questions here in a simple cheat sheet. So you can ask yourselves and your team the same questions to determine when to adopt this tactical forking. If your answer is yes to all these questions for your software project, tactical forking might be the viable strategy to grow your software and your team. In the next section, we will examine how to practically adopt tactical forking as a strategy for this purpose. I hope that everything is clear for now, and let's move to the next section. All right, guys. So by now, you know what this tactical forking is and when it becomes a viable option. The next question is, how do you practically adopt this strategy? Let's see. The first step is to evaluate what you would need to copy your code, your clone, so that another team has a copy of the software architecture that they can independently grow and own. So what do they need? You have to ask yourself. Do they need a copy of the backend API, the backend database only, or do they need a copy of the entire front-end application as well, the backend and the database? In your average scenarios, actually, you will only need to clone the backend API and its database, as they contain all the data and functionality. For example, all the business logic and the main things we want to grow and enhance. Usually, the front-end application is only a thin layer, and therefore, in this example, we will only focus on the backend APIs and the databases. Before we physically thinking about cloning anything, the next step is to identify different business areas within your software as a logical modules, which we discussed in the previous section. So, depending on what areas you will work on and how many additional teams you will have, we create a copy of the backend API and its database for each of these business areas in your source control system. While talking about cloning stuff, by the way, in the source control, tactical forking is known as a tactical forking because it becomes the forking aspect of its name from the source control terminology. In the source control terminology, forking means creating a copy of the code as a separate branch that you can work on independently. And it's not only the code you need to copy in the source control for each team and each business area, but you also need to create a copy of the entire deployment pipeline for each new clone version of the code so that each team can work and deploy changes independently without affecting each other. So each team needs to have its code in the source control and its build server to build its versions of the code independently. They also need their deployment server configuration to independently deploy the release to their deploy and release their code version. Ideally, they also need their development and testing environment to independently verify their changes in terms of upgrades and fixes. Once we have tactically forked our code and deployment pipeline into business domains, we then need to ensure we have a clear ownership, because without ownership, there is no communication will happen and nobody knows who is responsible about what development team owns what business domain. This is very crucial part of the also this kind of identification. Our team can work independently because they have their own code and deployment pipeline. And when they need to work together, there is a clear ownership and no confusion around who they need to work with. Once the team are set up, the next stage of fun really begins. They can start enhancing their versions of the code and, and specific areas related to their business domain and began deleting parts of the code outside of their business domain. This process of enhancing and stripping away the code is known as refactoring, as all of us knows, and it's very best suited with TDD methodologies or testing. So when you have a regression, very large code base that with a testing code base that can really in regressive way test your changes and enhancement, you will be very confident to deploy early and in agile way. You can see the green areas here where each team has added new features or enhanced existing ones, and the gray areas represent the code that the team have to start to delete. The deleted code, related objects, and data are removed because they are outside of the team's business domain. Once we have these new enhanced versions, although we have multiple copies of the same original code, we still need to give the impression of one working backend. We can use routing mechanisms specifically configured for our tactical forking strategy. It will take incoming traffic and then intelligently forward this traffic to specific business areas to the correct clone copy of the original software architecture and now represents that particular business domain. Thanks to our routing mechanism, our front-end application now will be obvious that they are now talking to multiple backend APIs, means it's fooling them into thinking nothing has been changed. So the front-end team will always not affected by these changes because of this routing mechanism. By the way, these routing mechanisms can take many forms. You can have your custom backend for front-end API that carries out this functionality, or you can have a particular cloud-based component like an API gateway to do the same. You could even have some basic as load balancer that allow this configuration. So I have described how tactical forking can be made to work at a very high level. Still, you can use this example as a starting point for planning with your engineering teams. This summary will help you as a quick reminder of all what needed step to go for this migration. Before last, how tactical forking impact on our team and development. This is how you can argue with the business in order to accept your idea and to speak about it. So in the previous section, we have examined how to adopt tactical forking to grow our software, right? This section will discuss the strategy impact on our teams and our software development. And one of the first things that we need to consider is the knowledge handover. This is because it doesn't matter how conventional your software architecture is, if it is an extensive system, it's bound to have subtle details that must be communicated to other teams that inherit your code. So when you carry out the first step of tactical forking, which we covered in the previous section, we give each team a copy of the software and their deployment pipeline. As a part of this, we also need to do knowledge handover. Your application is extensive and has many configurations and subtle details about how it works, how the data works together. When we copy a code and given it to another team, you will also need to hand over all this knowledge as a part of the handover, and can take time and need to be considered. So although I have said tactical forking is excellent way of getting your teams and enhance your software quickly, that's still true. Still, the greater your application's configuration and data complexity, the longer it will take time to the new team inheriting your code to get started due to this knowledge handover. The other impact of tactical forking that need to be considered is the impact on resources. You will need more resources to support all these extra cloned software architecture and extra deployment pipeline. These are data centers resources like infrastructure, hardware, software, on the cloud, on-prem. You will also need extra engineers to support all of this growth. So although tactical forking is a quick way to grow your software, in addition to setting up time, you will need an extra funding for extra resources that you will need. Why I mention all of this? Because you need to consider this into your migration and presentation to the business. It's not nice if you don't do all of this kind of analysis before you go to your business, because if you forget one of these, like the delivery time later on not agreed on and the budget they will give it to you, you cannot ask for more budget and you will end up failing because of resources, even if you are taking the right approach. So be careful of this. Another impact of tactical forking strategy that we need to think about is the impact of missing data and dependencies. How this could happen? So, as the team take their copies of the code and start enhancing their business domain and deleting code and data outside their business domain, there will be scenarios where this data overlaps. For example, when generating an order report using a new order API, we might need the product names stored as a part of stock API and maintained within the stock API database. Within the order API database, this data is missing because this order API no longer maintained it. And it was deleted because it's outside the order business domain. And this is logical. But now we are facing this problem. One solution in this scenario is to call the other API for missing data. So when incoming requests comes in and you need an additional data maintained by different API, you make a call to retrieve the data. It's very easy and very obvious solution. However, this comes with a cost. You need to have an API calling an API, which means your response to the calling application will be slower. Although this is an option, the impact on performance shouldn't be ignored. Using various technologies and design patterns to negate this impact would be the best. So in our case, another solution to this, you might guess it, and it's very easy to make all the components also independent for missing data to be available for others, is to use something like message broker to share data. So every time data is created or updated, a copy of the data is placed on the message broker. If another API or microservices need a copy of the data in their database, they can take a copy of the data from the message broker and store it into their local database. So this is more bringing more independency for the component to grow largely and control the data, and also introduce and give the missing data and share it between the services. So hopefully from these examples, you can see that although tactical forking is a very effective strategy for very specific scenario, it impacts our teams and software development in general. And we must come up with extra resource and solution to deal with this impact. Finally, let's see what is the challenges I have faced during this. So I'm summarizing this for you. Okay, in this section, we will look at some of the challenges, for example, disadvantage of adopting tactical forking as a strategy to grow your software. The first issue concerns code quality. As part of the strategy, we stripe away some of the existing code to create a new API. For example, a new smaller microservices specific to business domain. The problem with this approach, especially and specifically if you are coming from legacy application, is that you keep much of the legacy code. So regarding the code quality, your new microservices will be only as good as the old monolithic backend API and the backend database. So if you are previously had a poor coding and database standards, you would inherit many of these poor standards into your new microservices. However, you can tidy up the code and improve the design by adding new features, but with deadlines for a new features. We all know these ambitions sometimes need to be materialized. So be careful about this. Another challenge associated with tactical forking is centralized shared components. Even though each team has its copied code and deletes code outside of its business domain, common code and files must be still shared between these teams to avoid duplication. To avoid duplication, this common code and set of common files must be extracted, centralized, and shared between these teams. Shared between the teams as maintained centralized component libraries or packages. You will need, and we will need to assign to the extracted and centralized this code a specific team. The team must also manage this code long term as a centralized component with its deployment pipeline. The challenge here obviously comes from helping the teams coordinate to identify, extract, and centralize this component so they can be used by all the teams and avoid any kind of duplication. You see, there is more extra also funding required, which we didn't discuss before, but should be careful about your first analysis and gap analysis and also how you can move forward. We have spoke about this previously in this presentation. We also highlight the impact of logical missing data that has been separated into separate business domains, a separate microservices. We gave an example of the order API needing product names when generating an order report, product names stored in stock API and not logically in the order API. So as we have mentioned, the good news is that there is solutions to share data between microservices. The challenge here, however, is that we have a solution, but the solution will slow down our tactical forking strategy. Solution like microservices to microservice calls and message brokers to share data require specific technologies and design patterns before they can be implemented with desired performance and reliability. So yes, tactical forking is a quick way to grow software and support multiple teams. Still, many new technologies and design patterns might be required to support the new tactically forked software architecture. And again, to give you a head start with your tactical forking strategy, here is the summary of all the key tactical forking challenges mentioned in this section to give you a starting point to formulate your plan for these challenges. And by reaching this slide, I have finished with my presentation and gave you all the steps and knowledge about how you can move on and also what you need to consider for using this strategy as a movement from your monolith or even modular monolith or any kind of legacy system into distributed based system to achieve modularity and also a granularity. So thank you very much. I'm very glad that you are here listening to my presentation. If you have any questions, I will be very glad to take it.
Hi, that was a great session, Mohammed.
Thank you.
So I seem to have control of the questions. So when I see them, I can put them on the screen so that you can see them. There we go. Whoops, that's just me. How about this one? There was a real question. So considering that the monolith is under the responsibility of one single team, does it make sense to split it, even if all the answers lead to a microservice architecture?
It's very challenging because if you distribute it into multiple, because one of the question is, do you will have multiple teams to work on this like separated logical components? Because if it's only single team you have, you will waste time. Because they still have the ownership about all of this, but they cannot work concurrently. So you will face this problem. They will work, yes, you will divide your application into modular more application, but you require to hire a team. So it's one of the strategies to have ownership, multiple teams, to go for the market more fastly and in a timely manner way. So the team here is matter for the speed, how you can bring up these problems and features into the market.
Great. Let's go on to the next question. How does the tactical forking approach relate to the team's topology approach?
If I understand you correctly, team topology means like the structure of the team, how they are working like an agile or Kanban or these kind of things. It will be like communication, because now, if I understood you correctly about the team topology communication, they will be separately responsible about their own version of the code and pipeline and everything with their own infrastructure and DevOps team. And I was working in e-commerce application. For this regard, we have different 4 teams responsible about multiple microservices, not only one, because sometimes, yes, they are granular enough that one team can take care of 3 or 4 microservices, but they are also close related to each other, not very diverse in the functionality. So anything related to payment could be owned by one team. And it will make tactical forking, yes, because you are dividing team, they have their ownership, then they will have this collaboration. Each team can have Scrum Master, their own testers, or this formation of development team that support. And finally, they will communicate in order to make coordination for the changes for the whole bigger system. Yes, it affects the strategy even.
Great. I don't see any other questions. Here's your last chance. Get in here. Well, I assume you've all rushed off to our next session, so I'll let you enjoy that. Mohammed, thank you for an excellent session, and
It's my
I'll
pleasure.
see you at some conference somewhere. And to everyone who's
It would be
attended,
glad.
thank you.
Thank you very much. I will see some of you in the last presentation that I'm moderating. So it would be great, as well as the other speakers, great presentation. So please attend and have fun and enjoy. See you. Thank
Right.
you very much for
Bye-bye.
listening again, and have a nice day. Bye.